Hindi ko to lahat sasagutan ha. There are some items na sasagutan ko. Okay, so there are some items na sasagutan ko, pero hindi lahat sasagutan this time. Okay, so I want you to answer them na lang. Okay, so kayo na yung magsagot sa preferred time niyo. Okay, so yan. Pero i-upload ko yung solutions sa lahat by Sunday. Okay, so upload ko yung solutions by Sunday. Okay. For now, kayo na muna bahala mag-isip paano sasagutan niya ibang question. Okay? So let's start with the basic. Number 1. Number 1, no-brainer yan. Easy lang yan. Okay. Kumbaga, ito yung easy round. Typical seawater contains 2.7 grams of salt, sodium chloride or NaCl per 100 ml volume. What is the molarity of NaCl in the ocean? 10 seconds starts na. The joke. Okay, so ayan ito yung ating question. So, ano yung tinatanong? Molarity. So, kailangan, pag pumasok yung word na molarity, alam natin kung ano yung mga kailangan. Okay? So, ano ba yung equation for molarity? That is mole per liter. Diba? So, ang requirements for us to answer this problem is that we should know the moles of the substance and the volume of the solution. Okay? So, yun dalawa lang yung requirements. Okay? So, let's look at the given. No? Ano yung mga sinabi sa problem? We are given the volume of the solution. So, okay na tayo dyan. And the mass of the solution. So, ano pwede natin gawin? Mass yung binigay, hindi moles. So, pwede tayo mag-convert from mass to mole using the mass-mole relationship. No? So, we know that mole is equals to grams divided by the molar mass. Diba? The mass over the molar mass. So, we can expand this equation as the mass of NaCl divided by the molar mass NaCl times the volume of the solution in liters. Okay? So, ganun yung gagawin niya. Tignan niyo yung mga given. Kasi most of the time sa Anachem, lahat ng numbers na nandyan, gagamitin lahat yon. Okay? So, you identify lang ano yung sense ng numbers na yon and ano yung pwede gawin sa kanila. Okay? And then, since we know kung ano na yung gagawin, we have the mass. We have to convert it to the molar mass by dividing it by, we have to convert it into mole by dividing it by molar mass, diba? So, that is written as 2.7 grams divided by the molar mass of NaCl. Ito, given ba sa problem yung molar mass ng NaCl? Wala. Pero, may periodic table tayo. Okay? So, just look at your periodic table and tignan ang atomic masses ng Na and Cl. Okay. So, by the way, sa ating reference na periodic table, we are going to use all the digits. Okay? Lahat ng digits dito gagamitin natin. Okay? So, yan. Para uniform yung answer natin. Okay? So, for sodium, that will be 22.990. For chlorine, that will be 35.453. So, add nyo lang yan. Gumamit na kayo ng calculator, wag nyo na i-mental yan, sayang oras. Kunwari 1 hour lang yung quiz natin. Okay? So, sagot tayo ng mabilisan. So, the molar mass of NaCl is 58.443 grams per mole. Okay? So, we're good na. And we're left with the volume of the solution in liters. Okay? So, how are we going to convert ml to liters? Just divide it by 1,000. Okay? So, 0.1 liters yan. And check if the units will cancel. Okay? So, natanggal yung mga grams and we are left with mole and the liter unit. Okay? So, yan. So, yung mole dito, mapupunta yan sa numerator. Bakit? Because Sabi natin last time, if ang denominator ay may denominator, it reciprocates, no? Bumabaliktad siya. Yung denominator ng denominator, in this case, yung mole, magre-reciprocate yan, no? So that the mole will be on top, no? Pupunta siya sa numerator, and yung liter sa denominator, andun pa rin siya as is. So the final unit will be mole per liter. So yun yung mga elementary days natin na. So yan. So solving for the molarity. Let us represent the final answer in 2 or 3 decimal places. No? So ganun yung mga usual ganap natin. Kasi sa quiz, ganun din mangyayari. Yeah. So I will usually ask you to express your final answer in 2 or 3 decimal places. Okay, so bakit? Kasi pag kinonsider pa natin yung significant figures, I believe na-discuss na siya sa inyo. Okay. Kapag ginawa pa natin yung sigfig dito, baka mamali pa kayo lalo, no? So, okay na sa akin yung 2 decimal or 3 decimal places, no? So, for this item, mag 3 decimal places muna lang tayo. Okay. So, the molarity is 0.462 mole per liter. Diba? Easy lang. Actually, kaya yung sagutan in 1 minute, no? Daldal ko lang talaga. Kaya ang tagal natin. Okay? So, ganun lang. Again, ang tip ko sa inyo, sa Anachem, kung ano yung mga numbers na binigay doon, most of the time, you will use all of them. Okay? So, ang pinaka-important lang sa Anachem talaga ay alamin nyo yung proper equation to be used. Kasi lahat ng numbers halos gagamitin. So, you must identify if saan mo ilalagay yung mga numbers na yon by looking at your equations. Okay? So, yun. Yun yung tip number 1 ko sa inyo. Okay, so number 2, I will not answer this because this is very easy. So, okay. So, I will leave this item for you to work on after the class na lang. Okay? So, tuloy-tuloy lang tayo dito. Again, pwede mag-screenshot. So, pwede nyo i-screenshot yung sagot na yan. Yung number 2, kayo na bahala dyan. No? Kasi may weekend naman kayo. No? By Sunday, i-upload ko yung sagot dito. So, use the time in between those, in between this day and sa Sunday, no? Para magsagot-sagot na ito. You have to be prepared sa quiz 1. Always yung quiz 1 yung pwedeng mandali. So, ganun. Alam na ng mga students ko yan dati. So, next one. Find the number 3. So, I'm going to answer 3. Find the molarity and the molality of 37% by weight HCl. The density of the reagent is 1.19 grams per ml. Bago tayo mag-proceed sa calculation, siguro may weird kayo nakita sa problem. Ano 'yon? Yung molarity, common na 'yan. Pero ito, molality. Okay. So if you could still recall your Gen Chem 2 ng senior high school, molality is also a concentration unit similar to molarity. However, we do not use molality in Anachem, kaya hindi natin siya kinover, no? Pero since andyan yan sa problem na yan, didiscuss ko na rin. Okay? So we know that molarity is capital letter M, no? It is represented as capital letter M. And it has a formula of the moles of the substance being divided to the volume of the solution in liters. Yung molality, that is similar with molarity. Isang letter lang pinagkaiba nila. So, that means dapat may similarity sila. And yes, similar sila. Okay? So, paano? So, ganito. Nabubulol din ako. Ang molality Minsan nababasa ko yung morality, no? So, ang molality ay represented as small letter m. Naalala niyo pa ba yan? Okay. So, molarity, capital M, molality, small letter m. And the equation is similar. You have the moles of your substance in the numerator. However, in your denominator, instead of having the volume of solution in liters, what you have is yung kilograms of the solvent. Okay? So, ano yung big difference nila? Bukod sa isa yung big letter, yung isa small letter. Yung molarity, this is the volume of the solution. Solution yung nasa denominator ah, kapag molarity. Pero kapag molality, ano yung nasa denominator? Kilograms of solvent. Bumukas. Dito na lang. Okay. So ano yung nasa denominator kapag molality? That's kilograms of solvent. Bakit mass? Okay. At saan siya ginagamit? Okay. So the reason why sa analytical chemistry we use molarity is that we are dealing with liquid solutions eh. So that's why we use the volume of the solution. Puro liquids yung dinideal natin, mostly in anachem. Saan ginagamit ang molality? Okay. So yung molality, yan ay ginagamit namin sa physical chemistry. So physical chemistry is a branch of chemistry which focuses on the physical phenomena ng matter, no? Physical phenomena that happens sa matter. Ano yung behavior niya at different temperature, different pressures. Okay? So, yun. Bakit hindi ginagamit yung molarity sa physical chemistry? Bakit molality gamit namin? Kasi remember, last time I told you that at different temperature, yung volume ng solution, they change, no? Because of the expansion and the contraction of liquids. Okay? So that's the reason why in physical chemistry, we do not use molality. Nagbabago-bago kasi ang ano sabi ko, hindi namin ginagamit yung molarity, no? Kasi nagbabago-bago yung volume at different temperature. Okay? So, yun. Yun yung dahilan ba't reserve siya for physical chemistry. Pero yung for analytical chemistry, molarity is fine. Okay? So, yun. Then, ano mapapansin natin dito? Later on, mapapansin nyo that yung ating molarity and molality, ang values nila ay magkadikit. So, magkatabi lang yung values nila. Okay? So, yan. So, magkatabi yung values nila provided that the concentration is low. No? Pero kapag super concentrated yan, for example, yung number 4, makikita nyo there is a big difference between the two. Okay? So, yun ha. Remember the formula. Pakisave yung equation ng molality. Okay? And then, magsasagot na ako. Ayan. Ang dami kong kwento. Okay lang yan. At least nagsusulat kayo habang nagkukwento ako. Okay? So, start na tayo. Ano yung kailangan sa problem? Gagawin daw natin siyang molarity and molality. Ano yung gagawing molarity and molality? Yung 37% weight. Okay? Given yung density ay ito. So, dalawa lang yung given. Percent weight and yung density. And from those two info, kukuha tayo ng molarity and molality. So, ano yung pinaka-ginagawa natin dito? Ano yung pinaka-sense ng ginagawa natin dito? Basically, sa question na ito, we are going to convert one concentration unit to the other concentration unit. Okay? So, ganun yung gagawin natin. And question, is that possible? The answer is yes, no? As long as there are equations that could be related to one another, may sagot sa problem na to. Okay? So again, ang gagawin kapag ganito yung question, you're going to convert one concentration unit to the other. Okay? So analyze natin ano meron sa percent weight at sa molarity at para saan yung density. Okay? So ganito. So yung percent weight, this is the mass solute divided by mass solution. Okay? So yun yung percent weight times 100%. Tapos, ang molarity, this is mole solute divided by volume solution. Nakikita nyo yung relationship ng dalawa. No? Medyo similar sila. In the numerator, they both have the mass quantity of your solute. One is in mole nga lang, pero yung isa naka-mass. Can we convert mass to mole? Pwede. Ano lang gagawin nyo? Divide mo lang sa molar mass. Okay? So, ganun lang gagawin natin. Sa denominator, you have the mass of solution. Pagdating sa molarity, you need volume of solution. Is there a way to convert the mass into volume? Anyone can raise their hand para ma-recognize. Use your microphone para marinig namin ang answer niya. So is there a way to convert the mass of solution into the volume of the solution? Look at the problem. Tignan nyo yung given. Okay, so let's have Maria Angelina.
Hello, sir. Rinig po ba?
Yes po.
Using the density po. Ay,
Yung ano pa?
yung density po.
Ayun. So we will use the density formula. Okay, so thank you, Maria Angelina. Okay, kinumpleto ko talaga. So tawagin na lang kitang Angelina. Okay, so we will need to use the density formula to convert the mass into volume. Okay, so yun yung ating workflow. So bale, ang ginawa lang natin muna para alam natin yung steps na gagawin natin ay we check the relationship of percent weight sa molarity. Okay, so pag nakita mo yung relationship nilang dalawa, alam mo na kung ano yung mga kailangan mo kunin. So ano yung unang kailangan mo kunin? Mass ng solute. How? So we start with the percent weight. So kapag nakakita kayo ng percent weight, always assume that you have 100 gram solution. Always assume na 100 grams ang solution mo. Pwede po bang ibang number? Pwede, pero wag nyo na pahirapan sarili nyo. So 100 grams of solution agad-agad. Okay? And we know that the solution is composed of its components, no? The solute and the solvent. Question: if we have 100 grams solution, ilang grams yung HCl? E di kung ano yung percent na yon, 37 grams yon. Kasi 37% times 100 grams is 37 grams na. Yun yung purpose why we use 100 grams. Para kung ano yung numerical value ng inyong solute, kung ano yung percentage niya sa solution, yun na yung mass niya rin. No? So, wala ka nang ibang gagawin. Remove the percent, palitan mo ng grams. Yun na yan. Okay? So, yan. So, kung 37 grams ang HCl, question is, ano yung remaining 63 grams? So, kung solute yung 37 grams, edi solvent yung 63 grams. Alam ba natin kung ano yung solvent natin dito? Ang sagot dapat ay yes. Kasi sabi ko last time, in analytical chemistry, unless stated ang solvent, water yon. Okay? So, water yon most of the time, unless sabihin na iba yung solvent. Okay? So, our solvent here is basically water lang. Unless stated otherwise. Okay? So, dito pa lang sa assumption natin na 100 gram solution, we know that we can solve molarity and molality. Kasi ano yung meron sa molality? Kilograms of solvent. Meron na ba tayong mass ng solvent? Meron na rin, no? Ayan. Okay. So, ganun. Yun yung gusto ko gawin nyo. Tignan nyo muna yung, yung problem in a bigger picture. Tignan mo lahat ng equation at ano yung mga kailangan kunin na info na pwede mo magamit sa pag-convert, no? From one concentration unit to the other. Okay, so we're done. Tapos na tayo sa 37% weight. Ngayon, gamitin naman natin yung density. So, to convert the mass into volume, we need to use the density formula. So that's density mass over volume. Okay, so since we are looking for volume, we cross multiply yung D pati yung V. So we get M over D. So that's mass divided by the density. So yan yung equation na gagamitin natin. Sulat ko yan dito. Volume of solution, mass solution over density ng solution. So that will be 100 grams divided by 1.19 grams per ml. So we get the volume of the solution equal to 3 decimal places kapag mga in-between. No? Kasi pagdating naman sa final answer, rounded off lahat yon, no? Especially sa quiz. Nira-round off ko yung choices nyo doon. 0, 30, ano to? 34. Duling na ako. Okay? So that's 84,034 ml na. So yan. Ano susunod? Meron na tayong mass ng solute, may mass ng solvent, may volume ng solution. We can now solve for the concentration units na hinahanap natin. Okay? So, pwede na tayo mag-solve. Okay, so let's start with molarity. So that is mole divided by volume in liters. We can expand that as mass HCl, molar mass HCl, volume of the solution in liters. Okay, so mass HCl, that's 37 grams based on our assumption. The molar mass of HCl is, tingin sa periodic table, hydrogen 1008, chlorine 35453, add them. So that's 36 for 461. Okay, so 35 453 108. So that's 36 461 Gmol. Gmol talaga basa ko dyan, ha. Pagbigyan nyo na ako. Sanay ako eh. Then volume of the solution in liters. Hindi pantay. Ay, hindi sila hindi nagpantay. Ayan. By the way, kapag gagawa kayo ng ng fraction bar ng vinculum, it must be in between yung ating equal symbol nasa gitna, dapat siya ng vinculum. Gagalit yung prof ko dati kapag hindi pantay dyan eh. Engineer kasi yun eh. Okay. So, yan. Okay. And then, volume in liters. So, pwede mo ito i-convert into liters, pero hayaan mo na yung calcu gumawa nun. Okay. So, paano? You just copy this volume in ml. Sulat mo lang 84,034 ml. Then, i-divide mo siya. So, click nyo yung fraction uli sa calculator nyo. So, you divide it by 1,000 ml per liter. So, basically, what we're doing here is to convert ml to liters. No? Hayaan nyo na yung calcu nyo gumawa nun. I-type nyo na lang yung ganyan. Okay? Kasi, to be honest with you, pag sanay na kayo sa calculation sa Anakem, hindi na kayo magsusulat ng solution. Tina-type nyo na lang lahat sa calculator. Okay. So, ganun. Pag nasanay na kayo. Pero for now, ganyan muna. Ang gusto kong ma-develop sa inyo is yung magtiwala kayo sa calculator. Hayaan nyo ng calculator mag-divide niyan. Okay? So, magka-cancel yung grams. ml will also cancel out, giving us the unit na mole per liter. Okay? So molarity is, huwag nyo i-mental yan, may calculator. Okay, so the molarity is in 2 decimal places. Yun yung final answer natin. 12.08 mole per liter. Ayan. So, we're almost done. Next one, molality. Small letter M. By the way, kung ang molarity tawag doon ay molar, kapag molality tawag doon ay molal. Kaya nakakabulol talaga. Daming L. So yan. So molar dito, molal. Okay. So again, ang equation for molality is mole per kilogram solvent. I always indicate na solvent yung nasa baba. Yes. Kasi baka mamaya ibang mass makuha mo eh. We can further express moles as the mass HCl divided by the molar mass HCl times the kilogram solvent. Okay. Then let's plug in all the info. So we have 37 grams HCl. The molar mass still the same. Copy-paste lang yan. And for the kilograms of solvent, ano yung mass ng solvent? Okay, so sabi natin kanina, the mass of the solvent is 63 grams. Copy lang natin yan. 63 grams. Hala sir, kailangan kilogram. Dito mo i-divide by 1,000. Okay. Let your calculator do the conversion. Okay. Magtiwala kayo sa calculator nyo. Okay. Okay. So, sa portion na to, again, by dividing 63 grams by 1,000, we get the kilogram of the solvent. Again, solvent ha, hindi solution. Okay. So, kunin natin yung molality. So the molality is in 2 decimal places, 16.11 mole per kilogram. Okay. So the unit is mole per kilogram solvent. And as you can see, molarity and molality has their values near each other, diba? Magkadikit lang yung values nila. Okay. For dilute solutions, ibig sabihin kapag super onti yung solute nyo sa solution, the same ang value niyan. Same yung molarity sa molality. However, if your solute is bigger in quantity, pag dumadami na yung solute mo sa solution, doon na siya mag-start mag-deviate, no? So from unity, meaning nun, iisa yung value nila, it will start to deviate, no? Maghihiwalay na sila eventually, such as this example, no? Medyo mataas na kasi yung 37 grams, so medyo magkalayo na yung values nila. Okay, so that's how we convert one concentration unit to the other concentration unit. Okay, now if you have questions, you can drop your questions sa chat box natin, no? Okay, or you can raise your hand. Pero for the meanwhile, since okay pa naman ata kayo, I want you to solve number 4, itong nasa baba. Number 4 asks us to convert 49% weight of HF. Si Gabriel. Bakit 36,461 yung molar mass? Yun yung nakalagay sa periodic table ko eh. Check ko nga kung same lang din dito. Check ko lang. (1008) 3545 lang dito. Yung sa akin may 3. Okay. So, pwede na rin naman yan. Itong periodic table pala na ito yung yung hindi rin siya 3 decimal places, no? Pero, okay na rin yan. So, oo, 1008 yung H sa akin din. Pero yung CL ko pala yung complete decimal places dito. 35,453 sa akin. Pero ano lang yan, kapag ang changes na lang is yung thousandths position, that means yung 0.00 something. Kapag dun na yung may deviation, that's okay na. Okay. Tsaka eventually magra-round off din tayo eh. Okay. So yan. Ang gusto ko lang naman, kaya medyo similar yung periodic table natin is para kapag nag-round off tayo, we will still end up with the same value, no? Or at least within plus minus 0.03. Okay. So pwede ang makuha nyo 12.07, that's still okay, no? So basta yung mga within the small ranges lang, yung gap. Kasi kapag ibang periodic table yung ginamit nyo, yung as in 2 decimal places lang talaga or yung iba nga 1 decimal place lang, malaki yung magiging difference sa answer. So, pwede na yan na yung atomic mass na nakuha niya, molar mass. And wag na kayo mag-worry kapag yung bandang dulo na yung nagbabago. Okay? Let's have Rafren.
Sir,
Ano po?
ask ko lang po yung sa, di ba po, mole of solution po yung sa molarity and molality. So yung HCl po, sir, solution na siya.
Mole of solute yun.
Solute. Ay, oo.
Apo. Solute yun sa numerator.
Sige
Okay?
po.
Sige. So, basta sa numerator, solute, yun nasa baba, yun yung solvent or solution. Okay? So, yan. So, okay. So, with that, I want you to answer item number 4. I want you to calculate molarity and molality of 49% weight HF, hydrofluoric acid, and if the density of the solution is 1.16 grams per ml. So basically, kung ano yung ginawa natin dito, ganun din gagawin niya sa baba. Okay? So I want you to work on this. I will give you 5 minutes, to accomplish that. So I'll be back around 11:17 a.m. Okay? So yan. So sagot na po muna kayo. Then later on, I need 2 volunteers. Okay? So magre-raise ng hand, i-upload yung answer nila dito sa ating chat box. Then papakita natin sa class. Okay? So mag-ready na yung mga gusto mag-volunteer. Okay? So 5 minutes. Let's start now. By the way, screenshot nyo yung answer, ha? Kasi baka mamaya biglang mag-blackout yung screen. Okay? Okay, so let's have two volunteers. Okay, so may dalawa agad. Let's have um, Jan Gabriel Milano. Okay, former student ko yan. uh, so, so si Gabriel sa Molarity, no? And then let's have Daniela May Fran for the Molality. Okay, so si Jan Gabriel sa Molarity and si Miss Fran sa Molality. Okay. Meron pa namang ibang pwede sagutan later, no? So, yan. So, let's wait na lang until they send the pictures. Yan. Okay, so check ko yung answer. Excuse me. Lipat natin dito sa kabilang monitor. Okay, so zoom in tayo. Okay. So, ito yung solution for the molarity. No? So, again, every time you see percent by weight, always assume 100 gram solution. Sir, paano kapag percent volume yan? Di assume 100 ml solution. Diba? Pwede rin namang 1 liter or 1,000 ml solution. Okay? It's up to you. So, ganun. Pero, yun. Kapag mass, always 100% ang assumption. 100 grams ang assumption. Pero kapag volume, you can either use 100 ml or 1 liter. Okay? So, ganun. Okay, so yan. 49% hydrofluoric acid. So, that means 49%, 49 grams HF, 51 grams water. So, for the molality, that's mole divided by the kilograms of the solvent or the mass of the solvent. Teka lang, paano ba to? Wala, lumalayo na siya. Zoom in natin. Ayan. Ito na yung mole. Kinuha na pala niya yung mole. Okay, so to get mole, that is 49 grams divided by the molar mass of the hydrofluoric acid. Okay, so ito na yon. And then divided by the mass of the solvent in kilograms. And the final answer is 48.03. No? So, yan. Okay na yan. Okay? So, the answer is 48.03. Kapag within that range naman yung sagot nyo, 48.02, 48.01, that's acceptable. Okay? Okay lang yan. Pwede rin 48.05, okay lang yan. Okay, so thank you. Okay, so thank you, Daniela. Okay, so let's have Jan Gabriels. Wala, ba't ayaw na niya mag-zoom? Ayun. Okay, so we have 49 grams HF, 51 grams H2O. And this is the volume of the solution. Paano? Mass ng solution divided by the density. Okay. Then, yan. So I think this is grams per mole. So yan, grams per mole yan. So that's 49 divided by this grams per mole times this volume divided by 1,000. And the answer is 28.41 molar. So if your answer is within the plus minus 0.3 range, that's okay. Okay. So pwedeng 28.40, 28.42, that's acceptable. Kasi sa multiple choice, magkakalayo naman yung choices. Okay. So again, for the molarity, that's 28.41 molar plus minus 0.3. And then for the molality, that's 48.03 plus minus 03, no? Molal. Okay? So, all your answers are correct. Hopefully, yung iba, tama rin yung nakuha nilang sagot. Okay? So, once again, thank you, John Gabriel and Daniela May. Hopefully, yung iba, tama ha. If you have any questions, raise your hand or just type lang sa chat box. Okay? So, yan. Yun yung tip number 2 ko. Whenever you are dealing with percent weight or percent volume, always assume 100 grams kapag weight and then 100 ml or 1 liter kapag volume. So, that's tip number 2. Pakinote sa inyong notebook. Okay? Itong number 5, I will leave this to you. Kayo nang bahala magsagot dito. Kasi this problem is similar with the barium chloride dihydrate na diniscuss last time na. Yun nasa PowerPoint. So, yung way ng solution dito is similar with barium chloride dihydrate na. So, you are asked to prepare this concentration of copper. Copper 2 plus dapat yan. Typo lang. So, you're asked to get the this concentration of copper, no? So, ganito yung workflow niyo. Bigyan ko na kayo ng tip, pero kayo na bahala dito. So, gagawin niyo from molarity of copper 2+, gagawin mo siyang mole of copper 2+, and then you will convert it to mole of copper copper 2 sulfate pentahydrate, and then later on you convert into mass of copper sulfate pentahydrate. Okay? So, yun yung question. Yun yung process sa question na to. Okay? So, that's similar with, ano yun? Nawala ako. Gutom na to. So, that's similar with the question that is in your PowerPoint na. So, check nyo na lang uli yung barium chloride na. Pero, this time, may twist to. Ano yung twist dito? Ang twist dito is ito. Small m, big M. Baka isipin nyo, yan ay molal, molar. Walang ganon na. So, yung small m na yan, that is a Greek prefix, no? That's milli. So, ibig sabihin yan, millimolar concentration. What is the equivalence of millimolar with molar? The 1 molar equals 1,000 millimolar. Okay? Because again, yung concentration unit natin, pwede natin siya gamitan ng Greek prefix. No? Pwedeng maging millimolar yan, pwedeng maging micromolar, nanomolar, so pwede ganun. So yun lang ha. Pag nakakita kayo ng small m, capital M, that's millimolar. So that is 1,000th of a molar. Okay? So 1 over 1,000 ng molar. So I will leave this to you as your activity after the class or during your free time, kay bahala. Basta by Sunday, I will upload the answers. Then number 6, I will also leave this to you because this is a dilution problem. Okay? So easy lang yan. Let's have number 7. Basa. A solution of ammonia in water is called ammonium hydroxide because of the equilibrium ammonium in water equilibrates to form ammonium ion and hydroxide anion. Okay? So that's basic, no? Kasi may hydroxide. Okay? The density of concentrated ammonium hydroxide, which contains 28% by weight ammonia, is 0.899 gram per ml. What volume of this reagent should be diluted to 50 ml to make 500 ml pala to make 0.250 molar ammonia? So basically, ano yung hinahanap ng question? Yung volume ng original substance or ng reagent na i-dilute mo to make the final volume and the final concentration. So kumbaga, by looking at the last part of the question, this is dilution. No, dilution topic natin to. Dilution calculations to. And what's the formula for dilution calculations? MI, VI, MF, VF. Okay? So wherein if you multiply M and V, you get moles. So that means the initial moles is the same as the final moles of your substance. No? Nagbago lang yung molarity and the volume. Okay na sana to, madali lang sana to. Kasi alam na natin yung F, no? Ito yung MA, kamali pa ako ng line. So ito yung molarity final, ito yung volume final. Okay na sana. Tapos ito yung hinahanap. Pero what's the concentration of our reagent? Naka-molarity ba? Hindi. So that is expressed in percent by weight. So what I want you to do is ganito. So I need two persons uli, no? I need two people na sasagot ng problem na to. So one will convert 28% by weight NH3 into molarity. Then the other one will do the dilution calculations. Okay? So I will give you 5 minutes again to work on this problem. So I'll be back by 11:33. No? So ganun ang gusto kong ma-develop sa inyo, no? Basahin nyo ng buo yung problem, basahin nyo siya uli. Tapos tignan nyo, ano ba yung pinaka-main concept, no? So for this case, dilution siya. Okay na sana, pero ang problema natin ay yung molarity. Meron tayo percent weight, wala tayong molarity. So we have to convert this first to molarity so we can proceed answering the question. No? So ganun ang anachem. Okay? So ganyan ang anachem. Tricky, pero madali lang. Basta alam mo yung equations na gagamitin. Okay? So again, 5 minutes. Siguro ano na lang, 11:35, doon na lang ako babalik uli. So I will give you time to work on this and I need 2 volunteers uli later. Okay? So, yan. Good luck. Okay, let's have two volunteers. Two volunteers. Yung isa magsasagot ng molarity. Then yung isa sa dilution calculation. Okay, so let's have Oralita Espanto and Andrea Janine. Okay, so si Oralita Espanto sa molarity, and then let's have Andrea Janine for the dilution calculation. Okay, so let's wait until they upload their um, answers na lang. Download ko na lang yung picture. Ha? Wait lang. Okay, so this is the answer for the conversion of percent by weight to molarity. Okay, so ito yun. So we have 28 percent by weight ammonia. Okay, so that means if you have 100 grams of solution, you have 23 grams of ammonia in it, no? So, yan, kinonvert niya yung mass into volume using density, and then we ended up with 111 to 35 ml. Okay, good. Then, this is the molarity equation, mole per volume in liters, that is expanded to mass divided by molar mass times the volume in liters. Good. So, plug in. So, this is 28, the molar mass of ammonia. Okay, so 17,031, and then the volume of the solution in ml converted to liters also in the denominator, and then we have the final answer 14.78 ml. Okay, so that is correct, no? So yan, so hopefully everyone got the correct answer. So thank you, thank you, Aurelita. How about the ano naman, dilution? Okay, so about the dilution, wait natin yung answer. Okay. Sir, di ko sure. Okay lang. Tignan ka. Okay, so tama naman. Okay. So yun, tama yan. So let's have this one for the volume of the ammonia that is needed to be diluted to 500 ml. So we will have 0.25 molar ammonia. Okay, so this is the solution. So that's M1, MIVI equals MFVF. So since you're solving for VI, so we have the equation MFVF over MI. Okay, so the final molarity is 0.25 molar. The final volume is 500 ml or zero point 0.5 liters. And then the concentration initial is 14.78 molar. Yun na solve natin kanina. Okay. So we ended up with the volume 8.46 times 10 raised to negative 3 liters. Or if you're going to express that in ml, that will be 8.46 ml. Okay? So ganun. Pag dilution calculation, it's okay kahit hindi nyo na i-convert to liters. No? Pero this is correct pa rin naman. Okay? So the answer is in liters, 8.46 times 10 raised to negative 3. In ml, that's 8.46 ml. Okay. So if your answers are close enough to what was shown sa ating discussion, then you're good to go. Okay. So thank you, Andrea, Janine. So good work. Okay. And so ganyan yung style natin dito sa online learning. No? Wala tayong blackboard eh. Kanya-kanyang upload na lang. Okay. So that's how you answer number 7. Okay. For number 8, I'm going to answer this one. So this one is actually a gravimetric analysis, which will be discussed next chapter. Yes, chapter 3 yan. However, we can use the stoichiometric ideas dito, no? Para alam nyo na kung ano gagawin. Okay? So let's do this. No? Ito, kapit lang kayo. Stoichiometric conversions tayo. Okay. So let's have this one. In a gravimetric analysis, we need enough product to weigh accurately. Each tablet provides 15 milligrams of iron. So about 15 milligrams of iron per tablet. How many tablets should be analyzed to provide 0.25 grams of iron 3 oxide product? So ano gagawin dito? Ang gagawin dito ay ganito, no? So given that for each tablet, let's say ano to, ferrous sulfate, no? For each tablet of that drug, no? So it contains about 15 milligrams of iron. Okay? Ang kailangan natin is that malaman natin how many tablets would be equal to 0.25 grams of iron 3 oxide. So, nakita nyo na ba yung relationship from tablets to iron 3 oxide, no? So, parang yun yung gusto ng question na to. Alamin mo yung tablets, gano'ng karaming tablets, yung equivalent sa ganitong mass ng iron 3 oxide, given that each tablet has 15 milligrams of iron. Okay? So, paano ko po ito sasagutan, sir? Ganito lang. Stoichiometry. Okay. So, in stoichiometry, you always start with a given substance, no? When I say given substance, given yung formula, and given yung mass niya. Okay? So, alin dito yung given yung formula and yung mass? Obviously, ito. So, we will start with this one. Okay? So, ang gagawin natin, we will check, no? Kung ilang iron yung katumbas nito. Okay? So, basically, what we're going to do is from iron 3 oxide, aalamin natin how much iron ang meron dyan. And kapag alam na natin yung dami ng iron, we can use this info to convert that into number of tablets. Okay? So, ganun yung workflow natin. Okay? Always look at the problem sa bigger picture niya. No? Yung tignan mo siya ng malayuan. Okay? Tignan mo kung ano yung mga given, tapos ano yung mga pwedeng gawing process, no? Basta keep in mind lang yung basics, no? Ano yung basics dito in stoichiometry, okay? So, ano uli gagawin natin? Naburahin ko to. Ano uli gagawin? From the given substance, ganun naman sa Stoich, di ba parate? You always start with the given substance. Edi iron 3 oxide yun. From the given substance, you will convert that into amount ng iron. And then eventually, from amount ng iron, using this info, pwede natin malaman yung number of tablets. Okay? So, ganun. Ito yung question. Ito yung question natin. How are we going to convert iron 3 oxide to iron? Sagot ay Stoich. Stoichiometry tayo. So, paano yung workflow sa stoichiometry? So, paano nga ba yung workflow? Kung naalala nyo pa. Excuse me. So, paano yung workflow? You start with the mass of your iron 3 oxide. Okay? Start ka dyan. And then, you will convert that into moles of iron 3 oxide. Then, ano susunod? 4 na steps yun eh. Diba? I mean, 3 steps pala. So, from mass to mole, then from mole of iron 3 oxide to the mole of your desired substance. Diba ganun? Okay. Yan yung Stoich. Okay. So, again, from mass of iron 3 oxide, convert mo siya to mole. And then, from mole iron 3 oxide, gagawin mo siyang mole of iron. Stoich yun. And then, lastly, yung mole, gagawin mo siyang mass ng iron. And then, for the purpose of this question, alamin mo na yung number of tablets. Okay? So, 4 na steps yung ating solving for this item. So, this is reinforcement ng stoichiometry. So, ito na-discuss na yan last time. Last sem pa yan. Okay? So, I just want you to recall, no, yung mga pinagagawa last time. Okay? And yung possible application niya sa Anachem. You will see this type of problem more often pag nandun na tayo sa chapter 3. Okay? So, chapter 3 pa yung maraming ganyang questions. Pero sa ngayon, introduce ko na kayo sa kanya para hindi na tayo mahirapan sa susunod. Okay? So, let's start. Ilang steps? 4. 1, 2, 3, 4. So, we need 4 steps. That means 4 calculation to convert the mass of iron 3 oxide into the number of tablets needed to carry out this experiment. So, let's start. Calculation 1. So, that's mass to mole. Sulat natin. Mole iron 3 oxide is mass divided by the molar mass. Okay. So, ano yung mass? 0.25. Siguro dito na lang sa baba. And dito na lang. 0.25 grams divided by molar mass ng iron 3 oxide. Tignan nyo na ng periodic table. Times 2, 15, 999 times 3. So the molar mass of iron 3 oxide is 159, 687 G mol. Okay? So kunin natin. Three decimal places. 1.566 times 10 raised to negative 3 moles of iron 3 oxide. We're done with step 1. Ano susunod? Step 2. From mole of iron 3 oxide, you convert that to mole of iron. Paano? Stoich. Again, paano tayo nag-convert from mole of one substance to the other? We make use of their stoichiometric coefficients, okay? Or their mole relationships, no? So you start with the mole of iron 3 oxide. This is your given. And then you convert it into moles of iron. Sino yung nasa denominator para makancel? Yung mole ng iron 3 oxide. So that magka-cancel sila. Ano yung nasa taas? Yung mole ng iron. Kasi yun yung gusto mo eh. Mole ni iron. Okay? So, ang question dyan, okay, so yes, I have this format na. Ayun na siya, sir. Ano pa yung kailangan ko dito? Okay, so ganito. Di ba remember, kapag nag-stoichiometric coefficients tayo or stoichiometric factor, we need the coefficient, no? Kailangan natin ng numbers dito. Ganito gagawin nyo. Suppose you have 1 mole of your given substance. So, sulat mo dun sa baba, 1. So, suppose you have 1 mole of the given substance. How many moles of iron does it contain? Ilang moles ng iron meron ang iron 3 oxide? Anong gagawin nyo pag ganun? Pag ganyang question? Okay, so sabi ni John Gabriel, 2 because that is given by the formula. Okay? So, ganun gagawin nyo. So, if you do not know the mole relationship, tignan nyo lang yung formula. Ilang Fe ang meron sa Fe2O3? Or in chemistry words, how many moles of iron are there in 1 mole of Fe2O3? Ang sagot ay 2. Paano mo uli malalaman? Zoom in natin ulit. Yung subscript ng iron sa given compound. Okay? So that will tell you ilang Fe yung katumbas niya. So that is 2. So basically, what we're going to do lang is to multiply this number by 2. So times 2 lang natin siya. Kasi this times 2 lang daw eh. However, after doing this calculation, this is no longer mole of iron 3 oxide. This is now the moles of iron. Okay? So basically, kung ano yung solve natin, times 2 lang. So that's times 2. So we will get 132 times 10 raised to negative 3 mole of iron na. Okay? Remember, cancelled na ang iron 3 oxide. So yan. We're halfway. Halfway through this question. Number 3. What's next? From mole to mass. So that's easy. So paano yan? That's the mole of iron times its molar mass. Diretso ko na sa calcu para mabilis. 55,845. So that will be 0.1749. Kapayahin ko na lang. Okay. Ano to? Grams iron. So I have 0.1749 or 0.175. Gawin na natin 3 decimal place para consistent. 3 decimal places yung mga previous answers natin. Okay, so that's it. So that means, if we want to get 0.25 grams of iron 3 oxide product, that means we have to have 0.175 grams of iron. Okay? So, yun yung relationship nila stoichiometrically. Okay? May ganun bang word? Di ko alam. Okay? Pero yun, andun yung idea. By stoichiometric relationship, nakita natin that 0.25 grams of iron 3 oxide is equivalent to 0.175 grams of iron. Question, bakit ba natin kinuha yung mass ng iron? Kasi, pupunta na tayo sa next part. So, we are going to do ratio and proportion dito. Okay? So, we're going to do ratio and proportion. Ano sabi sa second sentence ng problem? Each tablet provides about 15 milligrams of iron. So, ibig sabihin nun, 1 tablet equals 15 milligrams. No? Let's convert that to grams. So, that's 15 divided by 1,000. Okay, so that is 0.015 grams iron. So, itong last part, this is just ratio and proportion na. Sabi sa problem, sa second sentence, isang tableta equals 0.015 grams iron. Ito yung susunod na tanong. Ilang tableta? How many tablets? How many tablet is equivalent to this amount of substance? Ito kasi yung kailangan sa reaction, di ba? Yan. So, ilang tablet yung katumbas sa ganyan? 175. So, yun yung question. Ilang tablets ang katumbas sa ganito karaming iron? Kasi yung ganitong karaming iron, katumbas yon sa ganito karaming iron 3 oxide, which is needed. Okay? So, kumbaga gumawa tayo ng indirect measurement, no? So, kinuha natin yung measurement ng tablets, no? By converting this iron 3 oxide to iron and then to eventually to tablets. So, ito yung tinatawag na indirect measurement sa Anachem. Okay, so quantitative analysis. You represented this molecule to iron and then eventually to tablets. Okay, so ganun. So, paano tayo mag-ratio and proportion? Ganito lang. 1 tablet equals this. X tablet equals that. Ano gagawin? Burahin yung equal sign. Lilagay sa gitna. And then, lagyan sila ng quotient bar. Okay? Or the vinculum. Lagyan nyo sila ng bar. And then, cross-multiply. Okay? Cross-multiplication na lang yan. And then, ayan, cross-multiply nyo na lang. Pwede nyo i-shift solve sa calculator yan. Marunong na ba lahat? I don't know. Pero turo ko na. Okay? Sa ibang subject, iba kong klase, di ko pa natuturo yung shift solve. Pero sige, sa inyo turo ko na. Okay? So, paano yung shift solve? Teka lang, tignan ko lang muna kung ano yung... Ayan, so tiisin nyo na lang ito. Ayan. Bulaga. Diyan yung mga mukha nyo. Okay. So, shift solve tayo. So, ano sabi natin doon? Diba gumawa tayo ng dalawang fractions? Okay. Paano sir maglalagay ng equal sign sa calculator? Ano ko lang yung ilaw. Ayan. Sir, paano ako mag-ano ng equal sign sa calculator? Kita nyo ba? Ayan. Paano po ako sir maglalagay ng equal sign sa calcu? Okay. If your calcu is Casio 991 ES plus or 570 ES or ClassWiz 970 EX or EX plus or something like that, you can use this technique. Pero kung hindi, edi hindi. Okay. So, ayan. So, paano po sir ako maglalagay ng equal sign? So, hindi mo pipindutin to. Kasi if you click this, solve niya yung operation. Paano po ako maglalagay equal sign? You can see the red equal sign sa calcu nyo. Ayun. So, in order for you to access that red equal sign, in my case, ito yon, you press alpha and that button, yung button na may red equal sign sa taas. So, yun ang equal sign. Okay. Yan. Diin na. So, that's the red equal sign. Okay. Kunwari naman, maglalagay ka ng unknown variable x. Tingin ka sa calcu mo, hanapin mo yung x na red. Ito yun. Ayun. Okay, so yung x na red nyon, that means if I press this button, lalabas yung x na yun. Pero hindi, parenthesis yung lumabas doon. Okay. So in order for you to access that x, you press alpha again, kasi kulay red siya, and then you press x. Okay, so ganun na ang technique ng calcu. Kapag gusto nyo ma-access yung red symbols, you press alpha. Kunwari ito, alpha A, alpha B, alpha C. Okay, so if you want to access the red highlights, press alpha. Pag gusto mo naman ma-access yung yellow, you press the shift. Okay, So, ito lang muna yung kailangan natin. Equal sign and then alpha x. Okay? So, yung equal sign, yun yung pang ratio and proportion natin. Yung x, this will be our unknown. O, type na natin yung yung nasa problem natin kanina. Sabi natin, kailangan natin ng dalawang fraction, may equal sign in between them. So, on the left side, andito yung tablets ko. So, 1 tablet equal, ano yung nasa tapat dapat? 0.015 milligrams iron. So, ito yung zoom in ko. So, ito yung 1 tablet, 15 milligrams iron. Ngayon, punta ako sa baba. Dito sa part na to, pag hindi nyo nasundan, panoorin nyo na lang uli yung video. Hangalay eh. Okay. Tapos itong nasa baba, ito yung X tablet, di ba kanina? Yung unknown. So, in order for me, para magkaroon niya ng X, you press alpha and then the button na may X sa taas. Huwag yung multiplication symbol yung X po na red. Okay? So, yan. So, X tablet that is equal to, lagay mo dito sa baba kung ano yung mass ng tablets na yon. So, 175 grams of iron yan. Okay? So, this is our ratio and proportion written in the calculator. No? So, yan. So, again, excuse me. So, again, ito. This is 1 tablet. This is 15 milligrams of iron per tablet. This is X grams of tablet. X tablet. And this is the corresponding mass of the iron needed. So, for you to solve that, kaya ang tawag namin dito, shift solve, kasi ipipress mo yung shift, press the shift, so kailangan lumabas doon yung letter S na yun. So, again, you press shift and then solve. Ayun yung yellow na solve. So again, shift, solve. So nakalagay dyan, solve for x. So pag nakalagay solve for x, gagawin mo, you press the equal sign, which is nabura na kasi super tagal na ng calculate na to sa akin. O you press equal sign pag lumabas yan. Okay, so ayan, yan din pala yung sagot. 11.66 something. Etong x yung sagot. Okay? So, ganun lang. If gusto nyo uli panoorin yung tutorial na to, just rewatch the video na lang sa YouTube, ha? Nangangalay na ako eh. Okay? So, according to our shift solve, madali lang to i-fraction, no? Pero ituturo ko na yung shift solve sa inyo kasi later on, magagamit nyo yan sa titration. Okay? So, I want you to develop those calculus skills. Kung alam nyo yun, edi very good. Pag hindi pa, ito na siya. Okay? So, X is equal to 11.67 tablets. Pero sabi ng doktor, sabi ng mga pharmacist, wag hatiin ang tablets, no? Unless baby ka. So gawin mo na lang yung 12 tablets. Okay? So, we need at least 12 tablets, no? So, we need at least 12 tablets so that we will have enough amount of iron, no? That is equivalent to this mass of iron 3 oxide, no? So, ganun po. So, basically, this is just Stoich. And ganito po yung itsura ng gravimetric analysis. Okay? So, you just convert one substance to the other. And then, kapag may mga ganito, convert the mass to number of tablets, number of sacks, no? Number of kung ano namang objects yan, no? So kapag ganun yung kinailangan, that's basic ratio and proportion na lang. Okay? So ganun po. So yun. That's how we answer number 8. You can take screenshot. Or pwede rin naman antayin nyo yung final answer sa Sunday. No? So, ganyan pa. Hopefully, nakuha nyo yung yung flow. Yun lang naman yung importante. Okay, so number 9 is similar with number 8. Okay? Pero hindi mo kukunin yung dami ng tableta. Basahin nyo na lang yung problem, pero I will tell you, similar lang yan ng process. Similar, not the same. So, kayo na bahala dito. No? So, kayo na bahala dyan. Again, sa Sunday yung sagot, ha? Siguro mga Sunday evening. Yan. Last one. Ito, ako na sasagot dito. Ito yung nasa PowerPoint natin. So, this is our last activity. And marami akong sasagutan. So, good luck sa akin. So, let's start. So, a solution was prepared by dissolving 1210 milligrams of K3FeCN6. The molar mass is given in sufficient water to give 775 ml solution. Okay. What? Anong what? Calculate pala. Calculate the molar analytical concentration of K3FeCN6, the molar concentration of K+, the molar concentration of FeCN6, the weight per volume percentage of K3FeCN6, the number of millimoles of K+ in 50 ml of this solution, the ppm of the anion, the pK+, and the pFeCN6. Kumbaga, ito yung pinaka-summary ng lahat ng ginagawa natin. So, let me solve this. Okay, so by the way, before we answer this, we should know first the dissociation reaction of the salt. No? So, this is a salt. No? Asin yan. No? So, it contains cation and anion. So, what is the cation and what is the anion? Okay, so, ganito gagawin natin. Usually, I will give you the dissociation reaction. Pero kapag simple compounds lang yan, kayo na bahala, no? Na-discuss na naman yan sa in-org. Okay, so what will be the dissociation reaction for this salt? So obviously, when you place your salt in water, it will dissociate into cation and anion. Question, ano yon? Okay, so bigay ko na. The cation here is K+, and the anion is the FeCN6 now. -3. Okay, so that's the charge of that anion. Sir, may metal sa anion? Yes, pwede po yan. No. So this is a part of analytical chemistry called complexation. Complexation. No? Tawag dito ay complex. Complex tawag dyan. Okay, pero I forgot the name of the substance. Okay. Pero yan, complex tawag yan pag ganyan. Pag may metal yung anion niya, complex. Okay? So yan. So these are the two ions, K+ and FeCN6, -3 on charge. So ano pa yung kulang natin dito? We have to balance it, no? So we have to balance it. So you can see, you have 3K ions. So that means 3K+ ang ating cation pag nag-dissociate yan. And then we only have 1 FeCN6, no? So that means 1 lang yung coefficient yan. Okay? So yan. So kailangan alam nyo yung dissociation reaction. Okay? Pag hindi, pwedeng ibigay ko. Pero kapag madali lang, hindi ko ibibigay. Okay? Kayo na bahala dan. Okay, ayan. So yan yung preliminary natin. Magagamit natin yan later. So let's start solving first. The molar analytical concentration of K3FeCN6. So when you say molar analytical concentration, that is molarity in long words. Kunwari naghahabol ka ng words sa essay, pwede mo iganyan yung term. Okay? So let's solve for the molarity of that salt. So let me write the concentration in square bracket. Again, kapag may square bracket, that's molar concentration. Para masanay kayo. So what's the molar concentration? That's mole per liter. So this is mole, volume in liters. Okay. And we can further expand this equation as the mass over from the mass divided by the molar mass times the volume in liters. And then, plug in na lang. 1210 milligram is 1.210 grams. So just divided by 1,000. The molar mass of the salt is given. So 329.2 grams per mole. Again, kapag given yung molar mass, yun na yung gamitin niya. Volume of the solution in liters. So we have 775 ml. So that's 0.775 liters. Okay. So the molar concentration is okay. So in 2 decimal places na lang, 4.74 times 10 raised to negative 3 mole per liter. Easy lang. So ganun lang, easy lang siya. Molar concentration lang yan eh. Yan. Okay, so ayan. Screenshot nyo na para sa mga mag-screenshot. Teka lang, i-compress ko na lang tong equation. Para malaki yung screen natin. Okay. So that's the answer for letter A. For items B and C, ito yung solution. Ano ba yung question sa B and C? The molar concentration of K plus and the molar concentration of FeCN6. Paano uli mag-solve ng molarity? Mass divided by moles divided by the volume. Okay? Given ba yung mass ng K plus? Given din ba yung mass ng FeCN6? Hindi, no? So, paano yun, sir? Ganito. Okay. If you are able to solve for the molar concentration of one substance, no? Pag nakuha mo na yung molar concentration niya, you can actually use stoichiometry to solve for the molarity of the other substances, no? So kapag na-solve mo na yung isang molarity, pwede mo gamitin yon to solve for the other molarities sa isang chemical equation. Okay? So using Stoich. So paano yon? Kaya nga kinopya ko tong equation na to, no? Bababa ko to. Kaya nga in-emphasize ko kailangan alam natin to. Kasi dito natin siya magagamit, no? So in such cases, no? Tulad ng problem na to, since na-solve mo na ang molar concentration ng isa, pwede mo na makuha yung molar concentration ng iba. Paano? Stoichiometry. Okay, so let me show you. So itong K3 FeCN6, this is 4.74 times 10 raised to negative 3 molar. Ngayon, yung K plus. Paano ko yung kukunin? Stoich lang. Kunin mo yung given concentration. Times, paano yung Stoich? Diba? Ito K3 FeCN6 to. K3 FeCN6. Ano yung nasa taas? Yung K plus. Ito yung gusto mo kunin eh. Then, kopyahin mo yung coefficients niya. So, for K plus, that is 3. For K3 FeCN6, that's 1. Okay? For this one, that is 1. Okay? So, basically, i-multiply mo lang to sa 3. You multiply this concentration by 3, and you will end up with the molar concentration of K plus in your solution. So, times 3 lang siya, according to Stoich. Okay? Again, paano mo makukuha to? Coefficients lang. Yung nasa baba, yung given substance mo, yung may molarity. Yung nasa taas, yun yung kukunin mo. Okay? So, ganun. Use your coefficient to get their multiplier. Okay, so basically, to get K plus, we just multiply this concentration by 3. So that becomes times 3. So yan ay 0. Kopyahin ko na lang lahat ng numbers. Ha? 0.01422. Ayan, kinopya ko na lang lahat. So that's the molarity of K+. No? Ayan. O ngayon, paano naman yung FeCN6? Yun yung nasa letter C eh. So for letter C, FeCN6. So tignan mo lang yung coefficient niya. So anong coefficient ng FeCN6? 1. Ano yung coefficient ng K3 FeCN6? Isa din. So basically, kung ano yung concentration ng K3 FeCN6, yun din yung concentration ng FeCN6. No? So parehas lang sila. So kopyahin mo lang. Yun yung mga shortcut dito. Okay? So instead na mag-solve ka pa ng kung ano-ano, gamitan mo na lang ng Stoich. No? Stoich is very useful. Okay? Basta tama yung gamit. Okay? So, yan. So, that's how you get the concentration of other ions given yung isang concentration lang. Okay? So, as long as alam mo yung dissociation reaction, alam mo yung balancing niya, use Stoich to get their concentrations and you're good to go. Okay? Proceed tayo. Letter D. Weight per volume percentage. So, sir, ano yan? Weight per volume. Wala naman yan last time. Oo nga, wala yan last time. Rare, rare unit of concentration to. Okay, so when you say weight per volume, this is like density. However, instead of the mass of the solution, you have your mass of your solute. No? So again, this is the weight solute, usually in grams. And the volume sa baba ay the volume of the solution, usually in ml. And you multiply it by 100, so you'll get the percentage. So ano to, hindi naman natin to gagamitin sa future. Naligaw lang yung question na to. So what's the weight of solute? That's ito, 1.210 grams. Volume of the solution in ml, that's 775 ml times 100%. So, ilan yung percent weight per volume niya? So, that's 0.156 gram per ml percent. Okay? So, yan yung kanyang weight per volume. Or pwedeng percent na lang, no? Pero again, this is uncommon concentration unit, no? So, siguro ito na rin yung last time na may kita nyo yan. Okay. Let's have letter E. Ano ba yung kailangan sa E? The number of millimoles of K+. Sige. Teka lang. Okay, so the number of millimoles of K+. Okay, so when we are abbreviating millimoles, ang sulat doon ay mmol. Okay? Huwag niyo sobrahan ng isang letter. Bad yun. Okay, so mmol. So that's millimole, no? So ito yung mole, yung small, yung m dun sa left side, yun yung milli. Okay, so that's millimole. Okay? So ganyan. So that's the symbol for millimole. So we are asked what is the millimole of K+ in 50 ml solution. Solve natin. Dito may two ways tayo sa pagsagot. Ito, technique number 4. Yung technique 3 ko, ito yung tip ko. Ito yung third tip, yung convert using Stoich, no? Yung concentration unit, pwede mo gawin ganyan. Pag molarity. Pero kapag hindi yan molarity, hindi mo pwede gawin yan. Okay? So, yan. So, letter E, dalawang steps, dalawang methods dito. No? So, pwedeng yung isa, pwedeng alternate. Okay? So, gawin ko yung conventional method. No? So, instead of solving for millimoles, we solve first for the moles. No? How do we solve for the moles of K plus? In 50 ml solution, do we know the concentration of K plus? Yes. No? Ito po yun. Yan. So, gagawin nyo, you multiply the concentration by the volume in liters. Ano yung makukuha nyo doon? Moles. No? Then yung moles, pwede nyo i-convert to millimoles. Okay? So, let's multiply the molarity times the volume in liters. So, that's 0.01422 divided by liters. Anong solution daw ba? 50 ml solution na. So, yan yung volume na gagamitin natin. Liters pala. 0.05 liters. Okay. Liters will cancel out. So, the answer is 7.11 times 10 raised to negative 4 mole. Then, ano susunod? Convert mo yung mole to millimoles. Paano? Fraction. 1 mole. Ilang millimoles kaya yung 1 mole? Di 1,000 kasi nga, milli. Okay? Cancel. So, the answer will be 0.711 millimoles. Okay? So, yan yung sagot. Haba, no? Haba ng solution. Ito yung shortcut. You can directly solve millimoles. How? You multiply the molarity by the volume in ml. Okay? Bakit? Kasi tignan nyo ha. Look lang. Kasi tignan nyo. Ulit-ulit. Okay, so ginawa natin, we converted ml to liters by dividing it by 1,000, di ba? And then later on sa calculation natin, we multiplied it again by another 1,000. Okay? So, multiplying it and dividing it by 1,000, ibig sabihin nun, magka-cancel lang yung dalawa. No? Magka-cancel lang yung parehas na 1,000. Okay? So, ito yung shortcut. No? So, instead of converting that to liters pa, no, for you to get the millimoles, you multiply it na lang sa volume expressed in ml. Kung ano yung value na makuha mo doon, milli na agad yung unit nun. Okay, so let's do that. Okay, so times 50 ml. Yes, the units will not cancel out kasi hindi na natin pinakita yung cancellation ng units, pero yung final answer niyan ay same lang. Okay, so millimoles agad yung sagot. Compare nyo naman ito sa ito. Haba, no? Ito, maigsi lang. Okay, so yan yung tip number 5. Okay, so kung gusto nyo ng millimoles, you multiply the molarity by the volume in ml. Okay, so ganun lang. Okay, and also from this equation, no, pwede mo rin malaman na ang molarity, pwede mo yan ma-solve by millimoles divided by volume in ml. Okay, so yun. So other than mole per liter yan. Okay, so pwede ring millimoles per ml. Pag dinivide mo yung dalawang yan, ang sagot ay molarity. Okay, so ganun. So yun yung mga shortcut. No? Okay, so let's continue. Letter F, ppm, FECN 6. Ay, kung gutom na kayo, kumain kayo ha. Okay lang. Pero makinig kayo sa akin. Baka mamaya, kumakain lang talaga kayo ng tuluyan. Okay, so let's have ppm of FECN 6, negative 3. Okay, what is ppm? That is a conversion, concentration unit, di ba? So, that means kung aalamin natin yung ppm ng FECN 6, dapat may idea tayo gano'ng karaming FECN 6 meron sa solution. Okay? So, do we have an idea already about the amount of FECN 6 sa solution? Yes. Asan yun? Ito. So, we have the molarity of FECN 6 na yun. No? So, basically, this is another conversion of 1 unit to the other unit. No? So ito, isa na namang conversion from molarity to ppm. So ganun gagawin natin. Kasi hindi naman given yung mass ng FeCN6. No? Ang given ay yung mass ng K3 FeCN6, not the anion. So you have to convert the concentration na lang to ppm. So ganun yung scheme natin ha, from molarity gagawing ppm. Okay, so let's do that. Paano? Okay, so from the molarity, kunin natin yung moles ng FeCN6. Bakit? Kasi ano ba yung ppm? So when we use ppm, that is the milligram solute per liter of solution. Sa molarity, ano meron? Mole solute divided by volume of liters in volume of solution in liters. Ito na yon, same sila dyan. Okay? Same yung dalawa. Can we convert mole to milligram? Mole and solute to milligram solute? Yes, di ba? Pwede yan. Gamit ka lang ng mass-mole relationship. Okay? So, yun yung gagawin natin. So, we convert the mole of solute to milligram of solute, and then we solve for the ppm. Okay? So, let me write the workflow dito sa taas. So, again, from mole FeCN6 to mass FeCN6 in milligram. Then eventually, we can solve for the ppm. Okay, so this requires two calculations lang. Basically, 3 kasi gagawin mo siyang milligram eventually. Okay, so yan yung workflow natin. Again, ganito yung gagawin nyo always ha. Sulat nyo yung equations, yung mga concentration unit, pakisulat sila completely. Then, from the contents of the equation, tignan mo kung possible yung conversion nila. Okay? So, yan. So, let us solve for the mass of FeCN6, negative 3 in the solution. Paano yan? O from mole to mass, start pala tayo sa molarity. Okay, kaya pala sabi ko 3 calculations. So molarity pala muna. No? So molarity FeCN6 to moles. Yun yung nakalimutan kong step. So let's do that. No? So from molarity to mole, ito yung step 1. I forgot. So mole FeCN6 negative 3 from molarity. Paano yon? At the molarity times volume, di ba? In liters. In liters, ha? Okay, so molarity, ano yung molarity nun? Hindi ko kabisado. 474. Okay, so yan. Tama ba? Okay, so that's 4.74 times 10 raised to negative 3 moles per liter times the volume of the solution in liter, which is 0.775. Sir, saan galing yan? Sa problem. Yan yung volume ng solution. Okay? So, yan. So, yan. Multiply natin yung dalawa. So that will be 3.634 times 10 raised to negative 3 moles. Okay, so that's the mole of iron. Ayan, yung FeCN6. No? So yan yung moles niya. Next one. Susunod. From mole ng FeCN6 papunta sa mass ng FeCN6, then gagawin natin milligram. Okay? So paano yon? Mass-mole relationship lang yan. Okay? So gamit ka ng mole, mass FeCN6 equals mole niya times the molar mass. Okay, so kopyahin ko yung mole. Ano yung molar mass ng FeCN6? No? Yung negative 3, charge yon. Huwag nyo papansinin yon. So, ang kailangan mo ay yung Fe, yung 6 na carbon, and yung 6 na nitrogen. Okay? So, yung iron, hanggang ngayon, hindi ko pa rin kapisado. So, that's 55, 845. Carbon, 12011. Nitrogen, 14007. Okay? So, times 6 yung dalawa because of the subscript, no? Outside the parenthesis for the cyanide ion. Okay? So, kunin mo yung molar mass niyan. Solve lang natin. So, yan. So, we have 1211.953 grams per mole. Okay? Burahin ko na. So, makukuha na natin yung mass ng FeCN6 na. So, that will be 0.770 grams. Okay, so we have 0.770 grams. And then, convert natin yan to milligram. So, 1 gram, 1,000 milligram. So, that's 770 milligrams. Okay? Ang haba ng solution, no? Ayan. Okay, so yan, that's 770 milligrams. And then, last step, finally, we get the ppm. So, paano kinukuha yung ppm? Milligram per volume in liters, no? So, ano yung milligram ng solute natin? So, that's 770 milligrams. Ano yung volume in liter ng ating solution? 0.775 liters. You divide the two numbers. Dividing the two numbers, we get 993.5 milligram per liter. Pag hindi ka nag-round off, no? Kunwari, tinuloy-tuloy mo yung numbers. If hindi ka nag-round off, ang makukuha mo dyan ay 1,005 milligram per liter. Okay. So, yun lang yung problem with rounding off. Dito nag-round off ako eh. No? Kaya, we get 993.5, no? Okay. Pero if you continue the numbers, no, kapag kinumpleto nyo talaga yung digits, you will get 1,005 ppm. Okay? So, yan. So, ano yung advisable? Mas maganda kung hindi nyo i-round off, especially in between calculations. Always the final answer. Ang reason lang ba't ako nag-round off dito is that it will take me lots of time. Okay? Mauubos yung oras natin sa discussion pag ganun. Okay? Ang important naman is yung flow. No? Pero yung calculations in between, as much as possible, wag i-round off. No? Yung final answer lang always. Kaso nga lang, ubos oras kapag ginawa ko yun dito. So, nagra-round off ako. Okay? So, yan. So, that's our answer. 993.5 milligram per liter of the anion or 1,005 ppm then. Okay? So, last two. So, we have G and H. So for G, we are asked to solve for the pK plus, and for H, we are asked to solve for the P FeCN6. That's p-value. Again, paano yung p-value? Negative log ng concentration ng K+. And for FeCN6, that's negative log concentration of FeCN6 negative 3. Do we know the molar concentrations? Yes, we know. Nasa B and C yan, di ba? So, kunin natin. For potassium, that's 0.01422 molar. And for FeCN6, -3. Ano yung concentration niya? 4.74 times 10 raised to -3. Okay? So let's solve for the pK and the PFeCN6 now. So solve natin. Negative log. Press nyo yung negative sa log ha. Negative log. Okay, so for pK plus, that is 1.85. And for PFeCN6, that is 2.32. Okay, so tapos na. By the way, negative yung pipindutin ha. Baka minus symbol yung pindutin nyo. Kapag minus symbol yan, ang lalabas ay syntax error. Okay, so kailangan yung negative. Okay, so we're done. So ayan, ito yung overall answer. Pwede nyo yun i-screenshot. Tapos i-save nyo sa phone nyo. O kaya hintayin nyo lang yung worksheet sa Sunday na. Yung answer sa worksheet na. Pero pwede nyo na yun i-screenshot. Then i-retry nyo na lang ulit. No? So check if you will arrive with the same answer. Okay, before I end the class, may isa pang akong problem na gusto sagutan. Before I end the class, ito muna. Kasi may ganitong question sa quiz. Hindi naman exactly ganito, pero similar lang. Okay, so question. Excuse me. About 22.5 ml of 0.75 molar potassium chloride was added to 30.1 ml of 125 molar potassium nitrate solution. Calculate the concentration of ions in the final solution. So, ano yung ginawa dito? You have a solution of KCl and another solution of potassium nitrate. Pinaghalo sila. What is the final concentration? Okay? Question, paano mo nga ba kukunin yung final concentration dito? So, ganito. If you mix two solutions, ano yung magbabago? Pwede magbago yung volume. Siyempre, magkaiba yan eh, no? So, pag in-add mo yung 22.5 ml, then 30.1 ml, so yung sum nun, yun yung final volume. As a result, ano yung pwedeng magbago? Yung molar concentration, no? Okay? Ano pa yung pwedeng magbago other than the volume? Yung moles ng substance, no? If you happen to mix similar ions, then that means dinagdagan mo yung moles ng ion mo sa solution. Okay? So in order for us to solve this problem, we should track, no? We should track the changes sa moles ng ating ions and sa final volume. Okay? So this is what we're going to do. So solve natin yung concentration ng K+, ng Cl-, and ng NO3- sa solution. So unahin na natin yung K+, no? Let's find the concentration of K+. So to solve for the final concentration of K+, we have to solve for the total moles of K+, divided by the volume total in liters. So yan yung gagawin natin, ha? Okay, so we have to solve for the total moles of K+, and we have to find the total volume of the solution in liters. Okay, so paano natin kukunin yung moles ng K+ in total? Ano yung sources ng K+ natin? So we can get our K+ here. Diyan. Kasi remember, KCl will dissociate into K+ and Cl-. 1:1 yung ratio nila. So kung ano yung moles ng KCl, yun na rin yung moles ng K+. Okay? Saan pa natin makukuha yung K+? Dito sa solution na to. So the ratio of K+ and the potassium nitrate is also 1:1. So you really have to know your dissociation reactions, no? So you can answer the problem. So that means alamin natin yung moles ng K plus dito, alamin din natin yung moles ng K plus doon, then saka natin sila ipag-add. Okay? For this question, hindi na ako magko-convert ng ml to liters kasi alam natin na pwede naman yung millimoles, di ba? Then kapag yung millimoles dinivide natin sa milliliters, pwede natin makuha yung molarity. Okay? So hindi na necessary na liters yung volume sa baba, hindi rin necessary na mole yung nasa taas. No? Pwedeng millimole over ml. You will get molarity. Okay? So let's do that. Ipag-add natin yung dalawang concentration ng K+, yung dalawang moles ng K+. So that will be 22.5 ml times 0.75 molar. So that will give us millimole of K+ from KCl. And then, ito naman, 30.1 ml times 1.25 molar. Naselect ko ba? 1.25 molar. So that will give us the millimoles of K+ from KNO3. Okay. Then we will all divide this by the total volume, which is 22.5 ml plus 30.1 ml. So 22.5 times 0.75, that's 16,875 millimoles of K+ from KCl. Okay. Then for KNO3, that's 30.1 times 125. That is 37.625 millimoles of K+ from potassium nitrate. Okay. And divide that by the total volume, 52.6. Okay. So after solving that, iurong ko lang muna to para may space tayo. So ito yung mga tips ko, ito yung mga lalabas sa quiz talaga. Kaya nga sinasabi ko na ngayon pa lang para ma-practice nyo na. Okay, so the molarity will be 1.04 molar K+. So that's the final concentration of K+ in our solution. Okay? So ganun lang gagawin nyo. You have to track. The volume will change talaga. So i-monitor nyo yung addition ng ng dalawang solutions, no? So magbabago yung volume every time you add another solution on top of the solution na meron ka. So magbabago yung volume. So you have to add the volumes parate. And then yung millimoles ng iyong ions, kapag parehas yan, kunin mo kung saan sila galing. So may potassium galing dito, may potassium din galing doon. So you have to add them para makuha mo yung total moles niya. So itong technique na to, this will not be only used ngayon pa lang kasi magagamit nyo rin to sa titration. Okay? So that's the reason why I am discussing this right now para familiar na kayo so that when we are in the titration steps na madali na lang yung calculation. So ganito lang din yung calculation doon. Super easy lang. Okay? So yan yung ating sagot for K+. How about How about Cl-? So how about the Cl-? Magbabago ba yung moles ng Cl-? Nadagdagan ba siya? Or nabawasan? Or the same? Well, look at the problem. Yung K+, madadagdagan yan, no? Kasi may K+ ka dito, may K+ ka doon. How about Cl-? Madadagdagan ba yan or same lang? Or mababawasan siya? So the moles of Cl- will remain the same. Okay? Ito lang kasi yung lone source ng Cl-. So kung ano yung mole ng Cl dito, Yun na yun, after the solution. Yun din yung moles niya after after mixing the two solutions. Okay? So, ganun yung gagawin natin. So, kunin natin yung millimoles dyan. So, conveniently, ando na yun. Nakasulat na sa taas. Okay? So, yan yung millimoles ng KCl. Saan, sir, galing yan? Dito. This times that. Millimoles ng K plus and also millimoles ng Cl minus. Yun na yan. And then yung final volume, ito lang yung magbabago for Cl minus. No? So, yan lang yung magbabago sa kanya. So, that's 22.5 ml plus 30.1 ml. So, you always have to check kung ano yung nangyayari sa ions nyo. Ha? I-monitor nyo yung nagbabago. So, the final concentration of Cl minus is 0.32 molar Cl minus. And then lastly, for nitrate, magbabago ba yung moles ng nitrate? Ang sagot ay hindi rin. Kasi ito lang yung lone source ng nitrate. So that means kung ano yung mole ng nitrate dito, yun na yun. Wala na magbabago. Okay, so ilang millimoles ng nitrate meron tayo? Well, lucky for us, nandito na yung sagot. This times this is 37 point something. So, yan na yung millimoles ng nitrate. So, multiply mo lang ito, pati yun. Yun na yung millimoles ng nitrate. Then, yung volume total, obviously, yung pa rin. Pwede nyo i-screenshot to, ha? Okay, so yan. Let me just solve this. 37,625. So, the final concentration of nitrate is 72 molar. So that's how we compute for the final concentration of our ions when we mix solutions. Now, and this technique will be helpful starting sa titration calculations natin. Kung ano yung ginagawa natin dito, ganun din yung ginagawa sa titration. So I want you as early as now to practice on this. Kung nakabili na kayo ng textbook and kung napadala na siya sa inyo, that's good. Pero if hindi kayo nakabili ng textbook, no? Or pwede nyo gawin is, di ba may books akong in-upload sa Canvas. Doon, sa chapter 1 ng Harris, yung questions dito, actually doon ko lang kinuha yun eh. Okay. So, puntahan nyo si Harris. No? Sa chapter 1 nun, yung chemical measurements, andun yung calculations. You can work on the last page of the chapter. Doon may mga questions doon na pwede nyo i-try sagutan. Okay? So, ganun lang. So, and also, pwede nyo rin sagutan to uli from the top. Bibigay ko naman yung answer sa inyo sa Sunday. So, I want you to be prepared, no? So, nakita nyo yung mga complexity ng questions dito. Ang daming pwede gawin because math, no? So, ayan, be ready na lang. Okay? So, anyway, as long as you know the concept naman, napansin mo iba-iba yung conditions pero iisa pa rin yung equations na ginagamit natin kasi ganun naman yung chem, no? The equation are the same, kakaiba lang ng conditions, no? So it is important for analytical chemist, no? Not only to be good at memorization but also good in analyzation. Nag-a-analyze tayo eh. For example, ito, paano natin na-solve yan? We analyzed, no? Whether magbabago yung moles ng substance, if or not, no? Whether magbabago yung volume or not, no? So, yun yung essence ng Anachem. It will help us to overthink, no? Mag-overthink talaga tayo sa ating mga calculations, no? Pero yung in a good way yung overthinking, no? So, at least nakikita natin na, nagbabago nga to. So, I have to account this sa calculation ko. Okay? So, I think overthinking in a good sense. No? Lahat na lang inisip mo saan galing sila. Pero good yan. Okay? So, yun yung isang virtue sa pagiging analytical chemist. Masyadong keen sa details. No? So, hopefully, ma-develop natin yan as we review for our quiz next meeting. Next week pala. I mean, hindi ako magpapa-quiz during our class meeting na. Okay, so ano lang. So, pwede kayo mag-take ng quiz sa day na gusto nyo. Pero 3 days lang yung allowed ng department. Tignan ko nga kung ano yung discussion natin next week. Nagugutom na ako eh. Teka lang. Lessons, lab, statistics lang. Statistics lang pala to. Dali lang to. Okay, so since statistics lang tayo next meeting, madali lang yan. Stats lang yan. Okay, so siguro ganito yung magiging arrangement natin, no? Punta tayo sa kalendaryo. Okay? Wala, magfe-February na. Grabe. Yes, ito March 15. Ito yung start ng midterm exam nyo na, no? Lapit na, no? Yan din yung anniversary ng lockdown. No? Happy 1 year. Okay, so andito na tayo sa last Friday ng month na to. Ay, salamat Jesus. Okay, so, di ba Tuesday tayo? Kasi yung ating stats kaya yun in one meeting. So, siguro gagawin ko na lang Monday, Tuesday. For Monday class ko and Tuesday class, wala muna tayong klase. I want you to focus on the quiz na lang. Okay? So, ganun na lang. Kasi yung stats pala tayo yung next chapter ay statistics. Madali lang yun. Ika-calculate lang yun. Turuan ko kayo kung paano. Okay. So, I'll give you time. Monday, Tuesday. Pwede kayong mag-quiz dyan. Then, statistics tayo on Friday. Okay? So, that's all for today. I hope na may mga nadampot kayo. Especially yung tips. Please, pakidampot sila. No? Yung tips, magagamit nyo yan sa Anakem. Okay? So, yan. So, I'll see you again next meeting. If you have any questions, you can message me naman. No? Okay? So, don't hesitate to ask. So, yan. So, thank you for your attendance and I'll see you again next week, Friday. Okay? Again, Tuesday, doon kayo magku-quiz. No? Although, pwede na kayo mag-quiz sa Monday or pwede sa Wednesday then. Okay? So, a copy of the class recording will be uploaded on YouTube. No? So, para sa mga hindi pa nakakalam, J. Kemi, ask your classmate na lang. Okay? So, alam na nila yan. So, yan. So, thank you for participating sa class natin. I'll see you again next week. Okay? Good luck and enjoy your review. Bye-bye po and ingat. Na-stop ko na ba yung recording? Ay, hindi pa.